What we're going to be learning today is the basics of networking in AWS. So in this case, we have if this is AWS, the cloud, we're going to see, next thing we're going to see is the placement of a region. So what we see here is a region. As we know, a region is composed of multiple availability zones. So I'm going to be drawing the different availability zones that this region may be comprised of. So in this particular region that I just drew, I have 3 availability zones. And basically what an availability zone is just, it can be one or more data centers inside of it. And remember that the availability zones are separated from each other by about 60 miles. That's the main idea. That if something were to happen to one of the availability zones, some sort of a physical disaster, it's going to be unlikely that's going to be affecting also some of the other availability zones. And also within the availability zones, you have good internet connections in between the different availability zones, so that they have very good network connection. Also, they have their own they're isolated in terms of the electrical power, in terms of the internet access that they receive. Each one of them is isolated. So if availability zone 1 were to go down, availability zone 2 and 3 would still be up and running. But that's the main idea of the reason why AWS created availability zones, so that if there was any failure within an availability zone, that failure doesn't spread to the other or others availability zones within that region. Now, whenever you create your VPC, which is going to be your virtual private cloud, the idea is going to be that your virtual private cloud is going to reside inside of a region. What that means is that your virtual private cloud can contain EC2 instances, for instance, or database instances inside of inside. It can potentially, just those databases could be potentially inside of each one of the individual availability zones, because your VPC spans multiple availability zones, and that's the way it is. Okay, so you just need to keep that in mind. So in this case, if this is your VPC that I drew in green, your virtual private cloud, which is your space on AWS inside of a specific region, it can have presence in the different availability zones that you have. In this particular case, I can choose either just to have a presence in one of them, or I can have the presence in all of them. Or so you can choose. It can be as few as in one availability zone, or you can have presence in as many availability zones as you want. And the type of what you're going to use as a container inside of your VPC that you're going to be placed inside of an availability zone is what's called a subnet. So it's going to be a subdivision of what a virtual private cloud is. So within your virtual private cloud, you can create many subnets. The reason why you create subnets in different regions, in different availability zones, for instance, is because you want to have different type of resources there. So in this case, I have drawn that in availability zone 1, in this availability zone, I'm going to place 2 subnets. And subnets are going to be the containers in which you're going to be able to place your EC2 instances, for instance, and also database instances. You're going to be able to place them there. So, so what is happening in this case, like I said, is that you have 2 subnets that you created in this availability zone. By the way, these subnets can be either public or private. When I say public is that I want this anything if a subnet is public, that means that anything that any EC2 instance, for instance, that is placed in here can potentially be accessible from the internet. So someone from the outside can come into this into my VPC and then come directly into the subnet and then eventually access the EC2 instance that I have here. Whereas you can also you can also have subnets that are going to be private. And as you can imagine, the idea of a private subnet, anything that's inside of a public subnet, a private subnet, is going to be any EC2 instances that you don't want to be accessible directly from the internet. Okay, so you don't want anyone from the outside to start a connection to machines that are going to be placed in a private subnet. But that's the main idea. So in this particular case, I'm going to indicate in a moment that that I want to make private. The subnet number 1 is going to be public, and subnet number 2 is going to be private. Okay, so now what we have here is that subnet numbers 1 is going to be public and subnet number 2 is going to be private. Now, by default, whenever you create a VPC of your own, that VPC is not going to be connected to the internet. You're going to have to add a new device, a new service. You're going to have to add a new virtual device that's going to allow you to have access to the internet, okay? And that device, I'm going to draw it. Once you create that device, for instance, suppose so this device is called the Internet Gateway. So the idea is that you need to create first. Once you create your VPC, then you can have you can add the Internet Gateway, because the Internet Gateway is going to allow us to have access to the internet. Okay, so what I'm going to draw in a moment is going to draw an internet gateway, and then that internet gateway, whenever you create it, it's going to be like floating in that region where you create it. So what you will have to do is you will have to attach it to the VPC. So remember, so if I were to create an internet gateway, it would be kind of like floating somewhere here in this region, but then I need to attach it to the VPC that I want to attach it to. So in this particular case, I'm going to attach it to VPC number 1. And the main idea of the Internet Gateway is that it allows traffic. It allows us to be able to communicate to the internet. We can initiate connections from the EC2 instances that are located in the, for instance, in the public subnet, to be able to communicate initiate communication to the outside. But it can also allow communications that are being initiated from the outside to be able to come into the internet gateway. So then that traffic is going to come into is going to go to for instance to subnet 1 in this particular case. So what I have done now is I have created an internet gateway, and also I have attached it to the VPC. And remember that what this is going to allow us is going to allow potentially we can have instances that are located in for instance in public subnets to be able to access the internet. And then any instance, we're going to see how instances that are located in a private subnet, how they will be able to access the internet. But in this particular case, they will be able to initiate connections to the outside, but they're going to have to be able to do them by means of another device that we're going to place inside the public subnet that will allow any instances that are inside of the private subnet to be able to access the internet. Okay, that's the main idea, because we have these subnets. This public subnet is going to potentially going to be able to access the internet. It doesn't mean that it can do it right away, because there are some entries that need to be created. There's something called a routing. To this subnet, there's going to be something called a routing table that is going to be associated with it, that will allow where we can indicate if you need to go out to the internet, go use the internet gateway as the way to go out to the internet. And then, like I said, if they communicate with some server on the outside, once the traffic comes back in, it will come back in through the internet gateway and then into the subnet. So what I'm going to draw now is I'm going to draw a couple of EC2 instances inside of the two subnets. Okay, so in this case I have drawn an EC2 instance in the public subnet number 1, and I have drawn an EC2 instance in the private subnet. Also, I'm drawing a relational database server here. Usually you do not want relational database servers to be accessible directly from the internet. That's why you put them in a private subnet. In this case, this EC2 instance here could easily be a web server, something like a web server. Okay, so what I have drawn here now is I have let's pretend for a moment that this is a web server. So this will receive incoming traffic that is originated from the outside, come into the region, then into your VPC, and then from the VPC it will find its way to the web server. Again, like I said, there's something that I still need to do, and that is called the routing table for this subnet 1. So now, like I said, I'm going to have to draw something called the routing table. The routing table is where I can create an entry that will indicate how these anything that's placed inside of this public subnet will be able to find its way to the internet gateway. So that's the next thing that I'm going to draw. I hadn't talked about it yet, but whenever I select a VPC, I need to select a block of IP addresses that I can use within my VPC. And in order to do that, I need to select a block of something called a CIDR block. So that's the next thing that I'm going to be writing down, what address block I'm going to be using. And then I'll explain to you how pretty much what happens. Like I said, the main idea with the IP address block that you're going to be assigning for your VPC is that you're going to end up breaking that up into small pieces. That address space is going to be used. Certain ranges are going to be used by your subnets, and that's the next thing that I'm going to create right now. Okay, so what I have created here is I'm indicating what is going to be the CIDR block that I'm going to be using for my VPC. In this case, it's going to be oh, I made a mistake. Sorry, I need to fix that. Right, just a moment. Okay, so the CIDR block that I'm going to use for this particular VPC is going to be 10.30.0.0/16. I'd made a mistake earlier when the CIDR block that I had used. Remember that this CIDR block refers to how many bits belong to the network, and the first octet here, or the first value here, we have 4 different values here, but the first value represents 8 bits. The second one also is 8 bits. What this means is that this network, this VPC, is going to contain any IP address that belongs here, any subgrouping of it that I create here is going to have the 10.30 is going to be fixed. The last two octets, the last two bytes that I have here, they can vary in value. And by modifying this first value, we can control, we can separate the individual subnets by controlling the third octet. This is the first one I can control. And then the last octet is going to be used for individual host or individual EC2 instance that I placed inside of that particular subnet that I create, for instance. Okay, so that's the main idea. Now, the other thing that I was going to show you was, in this case, by default, whenever you create, whenever you specify a CIDR block for a VPC, you are going to have a routing table that's going to be shared by all the subnets that are going to be part of your VPC. And so the main idea here is going to be the following. Okay, so continuing with what we have here, we have the destination. Any traffic that happens within your VPC is going to be part of the local traffic. So what is going to happen here is any traffic that happens within the VPC is going to be considered local. That's what we're trying to say here. Any traffic, and it makes sense. Remember, we selected this block for the VPC. So what that's going to mean is that any traffic that goes to any IP address that is part of this block that we selected for the VPC will be considered traffic, and not only that, it will be allowed. The next step is for this will be in general for all the subnets that you create there. Let's take a look at what subnet 1 is going to look like. So I'm going to write the routing table for subnet 1. So here is what is going to happen with any public subnets that you have. You're going to have the entry that gets inherited from the top, which means if you're going to go to 1030.something.something/16, the traffic is going to be considered local, and because of that, it will be allowed. On the other hand, if you want to go to any place out on the internet, then you're going to be using the internet gateway, and then there's going to be some sort of ID attached to that internet gateway. It's not just going to be IGW, it's going to be, say, IGW dash some sort of ID. But that's the main idea, how any machine, so we're going to attach this routing table to any public subnets. So what that means, like I said, we will have a routing, we will have an entry that says if you want to go to any IP address that is part of this range 1030 something something, that's going to be local traffic, allow it. If you want to go to the internet, or if you want, yes, if you want to go to the internet, then just use the internet gateway for that. Next, I'm going to show you what we do in order to be able to allow what is going to happen to any EC2 instances located in a subnet, in a private subnet, so they can access the internet. So what's going to happen here, when it comes to any EC2 instance that is located in a private subnet, in the private subnet that is going to be in the same availability zone as your private subnet, in the public subnet that is located in the same availability zone as your private subnet, you're going to place a device called the NAT gateway. As you can see, it's very similar in name to this one. This is Internet Gateway, this is NAT gateway. So the main idea about the NAT gateway is going to be that if any of these two machines need to go out to the internet And most of the time, the reason why they're going to want to go out to the internet is because they need to download some sort of updates to the operating system, or maybe updates to the, like in this case, in a relational database, to the relational database. So what we're going to do is, instead of going directly to the internet gateway, they're going to go to, in their routing table for private subnets, they're going to communicate through the NAT gateway. And the NAT gateway, because it's placed inside of the public subnet, it will be able to communicate with the internet gateway and be able to send the traffic out. And any traffic that comes in that was started by these machines will come back into the internet gateway. It will go into the NAT gateway, and the NAT gateway is keeping track of what machine in the private subnet made the request. So that traffic will be sent to. So if this initiated the communication to the outside via this route, then once the traffic comes back this way and then to here, that this one will send the response that whichever server out on the internet sent to the request that this one placed. But that's going to be the main idea. So now in the moment we're going to take a look at what the routing table for a private subnet is going to look like. So now in this particular case, I just wrote what the routing table of a private subnet is going to look like. It will also inherit the routing table that came with all of the that came with the VPC and anything inside of it, which is if you want to go to 1030 something something /16, that's going to be considered local traffic, which means allow it. Now, this 0.0.0.0/0 means the internet, same way as we did before. And in this case, what this says, if you want to go to the internet, use the NAT gateway as the means to go there. So if this RDS needs to communicate with the internet, it will do it through the NAT gateway that is placed inside of the subnet, inside of this public subnet. And then we'll be able to send the traffic out, then some server will reply, the response will come into the internet gateway, it will be sent to the NAT gateway, and the NAT gateway will send it to the RDS, for instance. But that's the main idea about this. The reason why I place these routing tables out here doesn't mean that the routing tables live outside of your VPC. These routing tables, they reside inside of the VPC. They are only known, the information here is only going to be known inside of this VPC, okay? But it's just due to reasons dealing with the space in this particular case. So the next thing that I want to explain to you is, as I mentioned before, we selected this CIDR block that is 10.30.0.0/16. And then I said that we're going to split it into smaller pieces, so then we can give certain range of values that subnets can use. So for instance, for this subnet 1, let me show you what IP address range it can have. So then it can have IP address, because because we're going to assign it a certain smaller range of IP addresses. What that means is we will be able to, any machine that you place here, they will be able to get an IP address in that particular smaller range of your VPC, okay? So in this case, what we have for the IP address ranges for the subnets that we have here, as you can see, what we're doing here is, we remember the 1030 we cannot modify. It's part of the CIDR block, is the fixed part of the CIDR block. Now when it comes to the something that we can do to differentiate different subnets from each other is by changing simply the third octet here. That's why in this subnet 1, which happens to be a public subnet, I am using the 1.0. Okay, and if you notice, this is a /24. What this means is that 24 bits are going to be fixed. So these 8 here are fixed, the second ones are fixed, and the third ones are fixed. So the only one that can change is going to be this one here. This is the only. So in this particular case, we're going to find out at some point that number of IP addresses that we can have here is going to be about 200. Remember yesterday I said that if you have the maximum of whenever you have a byte, that byte can be from 0 to 255. That represents 256 different values. So what is going to happen here is that we're going to have a certain number of IP addresses that are going to be available for anything that you place inside of that subnet. So we could potentially place about 251 EC2 instances, for instance, which would be way too many for a subnet, but that's the idea. And then, like I said, for the private subnet, the only thing that we're using to differentiate one network from the other is simply the third octet. And for this, so for the subnet that we have here, for this public subnet here, they will have values where the 10, the 30, and the 1 are fixed. The only value that's going to change is going to be the last octet here, which this is the value that can vary. And for this other subnet, we have 24 bits are fixed. So in this particular case, the ones that are going to fix are going to be the 10, 30, 2, and then the last one is the one that the host or the computers or the relational database servers can have. But that's the main idea about this. And then if I had created some other subnets here, I would have been able to use maybe 1033.0/24, and then I could go probably as high as maybe 1032.55.0/24, but that would be way too many subnets that we would have. Usually whenever you create an application in AWS, because if an availability zone goes down, the problem that you will have here is that anyone who was connecting to your EC2 instance, to your web server, for instance, in this particular case, would be able to they wouldn't be able to access that. What AWS usually recommends is that you reproduce whatever you have here, reproduce it in another availability zone. By doing that, you have some sort of redundancy, so that in the event that this comes down, then you can go to the other availability zone to get your anyone who coming from the outside can get their request served. But that's the main idea about this. Like I said, just to kind of like recap, if this is AWS, if this is a particular region, an availability region is made up of individual availability zones. In this case, I'm showing 3. And the next thing I'm showing is whenever you select a VPC, you're going to have to indicate what the CIDR block for that VPC is going to be. In this case, what I did was I simply selected the 10.30.0/16. What that means is that any subnets, any device that needs an and by the way, these values that I'm talking here, this CIDR block that I'm assigned, these IP values are not public IP addresses. These are private IP addresses. What that means is that these are only meant to be used inside of the VPC. They make outside of the VPC, they have no, they mean nothing. They there's no meaning to that, to this type of IP address outside of your VPC. So, and then the reason why we created this public subnet and then we placed, like, for instance, this server and the NAT gateway is because these devices, not only will they have an internal IP address in the form of 10.30.0.0, some in this particular case it would be for the private, for the public good. So it's going to be for these two devices, they will have an IP address is going to be 10.31 dot something in that format. But the idea is they will have, those are private. If you want to assign them a private IP address, you will be able to, I'm sorry, a public IP address that can be accessible from the internet, you will have to assign an IP address to this one. This is what we saw in the in one when I did the when I showed you how the how you, whenever you assign a public IP address to an EC2 instance, what happens. So that's what we saw. In this particular case, this NAT gateway is not going to have an IP address, a public IP address assigned to it the same way that we assign it to the web server that we saw in the example. Instead of that, what is going to happen is that this one is going to have what is called an elastic IP address. That is an IP address that doesn't change if you reboot the NAT gateway. That's the idea. That's the nice thing about the elastic IP addresses. They're going to be public IP addresses, but the good thing about them is that they the public the value of that public IP address doesn't change, and that's why we need elastic IP addresses. Again, whenever you create a web application in AWS, unless it's for like testing, you should recreate it also in another availability zone, so that in the event that this one goes down, the whatever you create, whatever you reproduce over here, will be able to serve the request from anyone coming from the outside to get data. I didn't mention, I haven't mentioned it, I didn't include it in this diagram, but each one of these devices here is going to have a security group attached to it. If you remember when I was talking about security groups, the security group, what it is simply a firewall that you attach to different EC2 instance. For instance, like I could have one here. I'm going to draw it in red. We'll see. This is going to be the security group. Okay, it's kind of like in orange, I guess. But this is going. What I'm trying to represent here is the security group that helps us protect the EC2 instance by limiting the type of traffic that we accept into it. So we can also place one here. Okay, so these circles here, like I said, they represent security groups that are going to be attached to the different either EC2 instances or RDS. This is a database instance. That's what this is called. And then the same way. So let me write it down here. So then, just a moment. So the next thing that I needed to include here was that security groups are firewalls that protect your EC2 instances. And network access control lists, we haven't seen this topic yet, they are firewalls at the subnet level. So if I were to draw, say here, some other device, in this case I can use, I'm going to draw this. In this case, what I'm going to draw here is what's protecting oops, what I'm trying to draw here is what is going to protect the subnet. Most of the time we don't touch this. Most of the time we don't touch the network access control list, the NAT, what's called in for short. It's they're called NACLs. Okay, so keep that in mind. So let me actually add some a little bit different. Okay, so this is the net. This is going to be the firewall at the level of the NACL is the network access control list is going to be the firewall at the subnet level, and like I said, we usually don't touch these things. And then whenever you have your application here and you reproduce it in another availability zone, either on this one or this other one, what you end up having is something called high availability. And as you can imagine, the name AZ availability zone comes from the fact that if you reproduce your infrastructure, your whatever you have in an availability zone, if you're reproducing another availability zone, you're going to end up having high availability, but also you have fault tolerance. There are situations where you can have instead of having one being kind of like the backup of the other one, you can have both your application that is in availability zone 1, for instance, and its clone in availability zone. Both of them can be serving requests coming from the outside. Both of them can be active. So what I'm trying to say is that they can share the load of all the traffic that is coming from the outside. There are some other cases where you have a copy, an exact copy of your infrastructure in one availability zone, which means the subnets as well as the contents of the subnets are reproducing another availability zone, but the whatever is here will only kick in only if one of the availability zone goes down. In that particular case, we're talking about something called a standby. So these other ones, if it was either one or the other that is going to respond requests, in that particular case, what you have is going to be what we have in this AC2 would be a failover, which means if this one fails, all the traffic is going to be sent to this particular availability zone here. There is more to learn about this regarding networking, but I think these are some of the basic, the most important aspects. Something that is common to appear in an exam is sometimes they ask you, can your VPC, which is here, can it span multiple regions? And the answer is no, because as we can see here, our VPC is contained inside of the region. It doesn't spill out into other regions. Another question that they can ask you is, how many availability zones can your VPC span? And it can span as many availability zones as you want. In this, like I said, so that's the main thing. Whenever you have a VPC, the VPC can have a presence in each one of the individual availability zones within that region. Another question that's important to that might appear you might be asked is, a subnet, can a subnet span more than one availability zones? And the answer to that question is going to be no. A subnet is contained inside of an availability zone. So even if I were to reproduce this infrastructure from here, were to clone it over here, I would be talking about subnet 3 and subnet 4, for instance, but it wouldn't be the same subnet 1. Subnet 1 is contained within the availability zone. And then also something important is you can have lots of subnets within your VPC inside that are being part of an availability zone. And other customers also, they can have their own VPCs and they can have their own subnets inside of their VPCs. And those subnets, again, are going to be contained within whichever availability zone they were created. So that's the idea regarding some of these topics. Again, in this particular case, what we have here is the security group is going to be what's going to be protecting the security group is going to protect our EC2 instances. And remember, with the security group, pretty much if we have a web server, we need to enable we need to have something called a rule, and that rule is going to be an incoming rule, which means it's traffic that comes from the outside into this VPC, into this EC2 instance. We need to have an incoming rule that says accept traffic coming on the protocol HTTP. HTTP, by the way, is associated with a port number 80, and then you would be saying allow traffic coming from, and then you would specify, if you indicate that you want the traffic to come from the internet in general, then you would type in 0.0.0.0/0. And for instance, the security group of this EC2 instance NF, this RDS here, is very likely that they might have, they may only accept traffic from, for instance, you can explicitly have them accept traffic from these servers, from, for instance, from the web server, as well as from, well, they have to accept they need to accept traffic from the web server in this particular case. I'm not drawing any more EC2 instances that we could have. There's some particular case where you might want to administer this EC2 instance. Like in this particular case for this web server, I could open port the port related to SSH, the inbound port SSH. This is the one that we saw in the example that we did the other day when I created a web server, that I opened port 22. That was SSH. That's what I did the remote session using the command prompt. But that was the idea there, that I was accepting traffic of type SSH into my EC2 instance, because this EC2 instance happened to be a web server. Okay, so I think this is all for now. So again, remember, you first create your VPC, you assign it the CIDR block that you want. The other thing so once you do that, then you can start creating your subnets. And the subnet, what is going to be, is going to be a partitioning of your of the space that you have here, of the space that was part of the VPC. So then you can start partitioning here. It's very common that one of the first things after you create your VPC is that you create an internet gateway, or if you already had one created from before that you will not use it, you would have to either create a new one or attach an existing one that is not attached to another VPC and attach it to your VPC. So then that you can potentially have traffic coming into and out of your VPC. And then the other thing that I need to mention was, or to remind you, was the role of the NAT gateway, because we don't want these ones to be accessible to the internet at all directly. At least we don't want traffic coming from the outside trying to access this EC2 instance, EC2 instance as well as this database instance. What we're going to do is we're going to use the NAT gateway as the intermediary to be able to communicate to the outside. And then so if this one needs to get some updates from say from from maybe this is Ubuntu, the Ubuntu web server, the Ubuntu Linux distribution, and it needs to get some updates. It would go out through the NAT gateway, and then the NAT gateway through the Internet gateway, and then go to the wherever the Ubuntu updates are being stored, and then once you pull that update, it will come into here, and then it will go into the NAT gateway, and the NAT gateway will send it to here. But again, so what is happening here is that this NAT gateway is acting as the intermediary between these instances, this EC2 instance and this database instance, in between them and the internet. So the NAT gateway is the one that's putting the requests on their behalf. And I believe these are some of the main topics. There are some other networking concepts, but I think these are some of the most important for the time being.